Hello guys, good evening, good day to you, and welcome to our class for today. This is Normal Science Tutors Online, and I remain your online tutor, to Michael. For our class today, we'll be looking at different types of AC circuits. So, well, our class for today will cover L arrow AC circuits, ROC AC circuits, LC AC circuits, and LROC simple series AC circuit. So guys, as I've always said, get your writing materials ready, your pen, your calculator, your paper, and then get settled down so that we can go straight to our class for today. But before we go on, if you are just visiting this site, this is Normal Science Tutors Online, and this particular video is for physics. So please, if you have not subscribed to our channel, please subscribe to the channel, click on the subscribe button, click on the notification bell so that whenever we upload a new video, YouTube will notify you, right? So, and also if you have any challenge, you can reach us through the WhatsApp number that's showing right on your screen. Is that okay? So please, if you are ready, we'll go straight to our class for today. I also want to encourage you to invite your friends to this particular channel, okay? And if you like what we're doing, give us a like, give us a thumbs up, and give us positive comments. As I've said, if you have any challenge in any of our videos or any topic in physics, you can reach us through the WhatsApp number that's showing on your screen. Okay, so please, if you are ready, let's go straight to our class for today. As I said, we are looking at different or various types of simple AC series circuits. AC series circuits. So if you are ready, let's go straight. Okay, so the first type of circuit we are going to be looking at is the AC circuit that contains a resistor and an inductor only. And such a circuit is also known as the L-arrow series circuit. The L stands for inductor, while the arrow stands for resistor. So this type of resistor is just this type of circuit contains a resistor and an inductor only, and since they are in series, this is a typical diagram of an AC circuit that contains an inductor and a resistor only. So this is your inductor, and the symbol for inductor is L, and then this is your resistor that is in series. This is the voltage to the circuit, and this is the frequency of the circuit. So this circuit drawing represents a simple resistor, inductor, or inductor-resistor series circuit. Okay, so for this particular circuit, remember that we said that for this particular circuit, the impedance is given by Z. Impedance is also known as reactance. I hope you remember that from our previous video on the AC circuit. So the impedance of this particular circuit is given by Z. L arrow is equals to V square root of the square, okay, the square root of the sum of the squares of the resistor and the inductive reactance of the inductor. XL is inductive reactance, remember. So XL is inductive reactance and R is resistance of the resistor. Alright, so from our previous video we discuss inductive reactance. Okay, so I hope you have not forgotten, but if you have forgotten, you can go back to that video where we discussed the inductive reactance of an inductor, right? So the impedance of this LRO series circuit is given by the sum of the squares, the square root of the sum of the squares of the resistance and the inductive reactance. Okay, then the peak current is equals to voltage over the impedance. Voltage, that is the peak voltage all over the impedance. This is the peak voltage, and then this is the impedance of this particular series circuit. Don't forget, when we treated simple AC circuit, we derived this simple equation. Remember that inductance or voltage is equals to IR. Okay, so if you are dealing with a capacitor, you will change this arrow to capacitive reactance. If it is an inductor, you will change this one to an inductive reactance. Is that okay? So that is how we apply this equation in our previous video. So your VO for this particular circuits, VO is peak current, peak voltage. So VO is equals to your peak current, which is IO, multiplied by your impedance, ZL. So if you make your ZL your subject of formula, you have this to be equals to VO all over IO. That is peak voltage all over peak current. Okay, so that gives you peak voltage all over peak current. So your impedance is equals to the square root of the sum of the squares of the resistor and the inductive reactance, and the peak current is equals to VO, or peak voltage all over inductive all over the impedance of this particular arrangement. All right, so in this particular arrangement, the current leads the voltage by an angle of 90 degrees, and the phase angle is equals to the inductive reactance all over the resistance. Then the total voltage for this circuit arrangement is equal to the sum of the squares, or the square root of the sum of the squares, or the voltage across the resistance and then the voltage across the inductor. So V arrow square is the voltage across the resistance, and VL square is the voltage across the inductor. So this is the formula for the total voltage that is flowing through this particular circuit. Alright, so we'll go straight now to see the application of these equations that we have just discussed. Because it is better you apply this equation for you to understand them. But remember from our previous discussion that in your study of resistors and resistance, that voltage is equals to what? Current times resistance. So as I said, where you have your resistance, if you are dealing with capacitors, you have capacitive reactance. If it is inductor, you have inductive reactance. And then if you are, for this particular resistor inductor series arrangement, in place of resistance you have the impedance, right? So impedance is equal to peak current all over, peak voltage all over peak current. Okay, so these equations, you have to be familiar with them, and then the peak current is equal to peak voltage all over impedance, and then you have the total circuit voltage, which is equals to this voltage is equals to the square root of the sum of the squares of the voltage across the resistor plus the voltage across the inductor, right? So let's solve some problems so that you get a better understanding. Okay, so in this particular question, the question says that an inductor and a resistor are connected in series in an AC circuit as shown. The voltage across the inductor and resistor are 20 volt and 18 volt respectively. Calculate 1. The supply voltage, 2. Current flowing in the circuit if impedance is 15 ohms, and 3. Inductance of the coil if the frequency is equal to 100 over pi. So this is the picture of what this question is talking about. All right, so for us to solve this problem, you first of all, normally you bring out what you have been given, then from there you can begin to apply the equation that is applicable, right? So in this particular question, you have been given the voltage for the resistor and the voltage for the inductor. So voltage for the resistor is equals to 18 volts. Voltage for the inductor is equals to 20 volts. You are also given the frequency to be equals to 100 over pi, and you are asked to find 1. The voltage, the supply voltage. That is the first thing you are asked to look for. You have to find supply voltage. Then after you find the current flowing in the system, then you also have to find the inductance of the coil, which is L. You have to find the inductance of the coil, that is ZL, SL. So these are the variables you are asked to look for, and this is what you have been given for this particular question. Now, to find the supply voltage, remember that we said that voltage, the total voltage that is flowing in the system, is equals to the square root of the sum of the voltage of the inductor plus that of the square of the voltage of the resistor. Okay, so that is the equation that we got before now. So you ought to do is just substitute these values into this equation to get the supply voltage. Alright, so if I substitute that, I'm going to have the square root of 18 18 squared plus 20 squared. So if I work this out, I'll have 18 squared is 324 plus 400. Okay guys, work that out from your calculator. If you work that out from your calculator, you have square root of 724, and then if you find the square root, you are going to have V is equals to 26.9 volts. Okay, So this is the supply voltage. So we've gotten the first part of this equation. Let me just rule that out. Now the second part is the current flowing. Second part is the current flowing. Okay, so for you to get the current that is flowing, you must first of all, you already know the voltage. Okay, you know the voltage, and they said that calculate the current flow in the circuit if impedance is given to you to be 15 ohms. So I didn't even bring that out initially. So they were giving the impedance of this circuit to be 15 ohms. Sorry about that, I didn't bring that out. Fine. So from the equation we had at peak voltage is equals to current times impedance. So the current flowing is equals to voltage all over impedance. So we can just from there get your value that current flowing I is equals to the voltage. That's what we got just now, 26.9 all over the impedance, which is all over 15. So if you work that out, you have that current flowing is equals to 1.79 ampere. Okay, so that gives you the current flowing. Now the third part of this question says that you find the inductance of the coil if the frequency is equals to 100 over pi. Alright, now from our previous discussion or from our previous video, before you can find the inductance of the coil, you must first of all look for the inductive reactance of the coil. Okay, so because here we have the voltage of the inductor, and then we have the current that is flowing through the coil. This is the current that is flowing through the system. So VL is equals to current times inductive reactance. So XL, which is the inductive reactance, will give you the voltage all over current. So if you substitute into this, the voltage of the inductor is 20. That is the voltage of the inductor. Then the current flowing through the inductor is 1.79. That's what we've got here. That's what we have here. Okay, so the inductance of the inductor, the reactance of the inductor is equal to, by the time you do this division, you're going to have 11.17 ohm. 11.17 ohm. That is the reactance of the inductor. Then we know that the reactance of the inductor XL is equals to 2 pi FL. So what we're looking for is this L. That is the inductance of the coil. So you make this L the subject of your formula so that you have L is equals to XL all over 2 pi F. Okay, so you can substitute all these values into this particular equation to get your inductance. So XL is equals to 11.17, okay, all over 2 multiplied by pi multiplied by 100 over pi. That is the frequency. Okay, so this pi will cancel this. So you do all this division, you have that your L, which is the inductance, will give you 0.056 Henry. 0.056 Henry. The unit of inductance is Henry. So this is what you have. So this is how to go about this particular type of question. Is that okay? So if you look at this question typically summarizes all the equations that we just discussed previously. Okay, so this is the supply voltage, which is total voltage. This is your current, which is the peak current or the current across the circuit system. Then this is the inductance of the coil. So this is the inductance of the coil, and the total of the coil is the inductance of the inductor, right? So please, this is how to go about this type of question. All right, so I hope this is clear. So we'll still solve another problem. All right, so this is another question. This actually a JAM question, and for JAM questions, they are typically short and direct to the point. Okay, so this question says that in the series circuits shown above, the potential difference across the inductor is 18 volt root meter squared, and the resistor is, and that across the resistor is 6 volt root meter squared. The voltage in the circuit is what? Okay, so this we have already discussed before, so I'm not going to waste time on this because this is a JAM question. So we have said that for an LRO series circuit, the voltage in the system root mean square, the voltage is equal to the square root of the voltage across the inductor, across the resistor. That is the sum of the square root of the sum of the squares of their different voltages. So this is what you have, and then you just substitute your values into this particular equation. So you have a squared plus c squared. As I said, this is a JAM question, and it is good that you understand the equation, then you know the particular equation to use. Okay, so once you know the equation to use, it becomes easy for you. So this is 64 plus 36, and this gives you square root of 100, and then so which means that the voltage you are looking for is equals to 10, volts, right? Okay, so that is the voltage you are looking for, 10 volts. Okay, so this one is direct and there's no ambiguity. Okay, this is direct and there's no ambiguity. Okay, so thanks. We'll see. Take another type of circuit arrangement. So this one is a resistor-capacitor circuit arrangement. This is a resistor-capacitor circuit arrangement. So in this circuit arrangement, you have a resistor and a capacitor connected in series. Okay, so just like the inductor resistance arrangement, that is how this one is. And if you look at the equations, they look very much alike. So the difference here is just for you to change the inductive reactance to capacitive reactance. Okay, so this is the only changes that I see here. Okay, so this is, instead of VL you have VC. Okay, so where you have XC you have XA, you have XC. So in this particular case, the equations are almost the same. Okay, so this is the impedance for this particular circuit arrangement, and all that we discuss in the LRO series arrangement applies here too. so there's no ambiguity or difference. All right, so what we're going to do now is to apply these equations in solving for in solving on the different questions. Okay, so that's what we're going to do straight away. All right, so this is a question that we need to solve, and this question says that a 40 microfarad capacitor in series with a 20 ohm resistor is connected to a 100 volt 50 Hz AC supply. Draw the circuit diagram for the arrangement and calculate impedance of the circuit, current in the circuit, the PD across the capacitor. Okay, so we are asked to draw the circuit diagram. All right, so I have already drawn it, so and that is what you have here, this circuit diagram for this particular question. Say draw the circuit diagram for the arrangement and calculate all this. So this is actually a wire question and it's a theory question. Okay, so you apply the way we solve the previous questions is the same thing that you are going to apply here. There is no ambiguity in this particular question. Okay, so for this question you are giving the capacitor, the capacitance of the capacitor is given to you, okay, which is 40 microfarad. The resistance of the resistor is given to you to be 20 ohm, right? And then this is the voltage of the circuit arrangement. All right, so first of all, we know that the impedance is given by impedance Z. So as I said, this is circuit diagram, so that part is taken care of. Then the impedance Z arrow C is equals to the square root of the resistance squared plus the capacitive reactance squared. Okay, so for this particular arrangement, you're seeing that you have been giving the resistance. Okay, so resistance have been given to you to be equal to 20 ohm. All right, but the capacitive reactance, you don't know it. So which means before you proceed, you have to find the capacitive reactance. Okay, so capacitive reactance XC is given as 1 all over 2 pi FC. All right, so frequency is given to you. This is the capacitance of the capacitor. So your own is to substitute the values into this equation. Don't forget that a microfarad capacitor, you have to convert it to coulomb. Okay, so convert that to coulomb. For the 40, you multiply that by 10 raised to power minus 6 to give you the capacitance in coulomb. Okay, so C is equals to this. So substituting into this equation, you're going to have 1 all over 2 times pi times frequency, which is 50 Hz. This 50 Hz frequency multiplied by the capacitance, which is 40 times 10 raised to power minus 6. Okay, so guys, use your calculators to solve this. When you use your calculator to solve this, you are going to have that XC, the capacitive reactance, will be equals to 79.56, 79.56 ohm. So this gives you the value of the capacitive reactance. Alright, so once you have gotten this, you can now substitute into this equation that we had. So if you substitute into this equation, that's impedance equals to square root. The resistance is equals to 20. So you have 20 squared plus 79.5 c squared plus 79.56 squared. By the time you multiply this out, you are going to have square root of 400. 20 squared is 400 plus a square 79.56 square is equals to 6329 6329.8. So by the time you add this up and find the square root, your overall answer will now be equals to 82.04 ohm. So this is the impedance of this circuit arrangement. Okay, this is the impedance of this circuit arrangement. Then the current that is flowing in this circuit, the current is equals to the voltage all over the impedance. Remember, so current is equals to VO all over Z RC. Okay, so remember this equation, we got this equation before. The voltage in this circuit is equals to 100 divided by your impedance, which is 82.04. So that is equals to 82.04. Okay, so by the time you work that out, you are going to have 1.22 ampere as your current. Then lastly, the PD across the capacitor. The PD across the capacitor, which is VC, is equals to the current in the circuit multiplied by the capacitive reactance. Okay, so we have gotten the current to be 1.22 and the capacitive reactance we got is 79.56. So do that multiplication, 1.22 multiplied by 79.56. Okay, so by the time you multiply that out, you are going to have that the voltage across the capacitor is equal to 97.06 volts. Okay, so guys, that is it, and that is how to go about this type of questions. So you can also see how all the equations are related. Okay, so we'll take another question. So this is a JAMB question, and as I've always said, for JAMB questions you don't waste time, so you go straight to the answer and then solve the problem out. In this question, you are given, this question says that in this AC circuit above, the current value is what? So you are asked to find the current that is flowing in this particular circuit. Okay, so here you are giving the resistance, you are giving the capacitive reactance, you are giving the voltage, and here you are also giving the frequency. So which equation should you apply? Remember that the impedance of this circuit Z RC is given to be equals to square root arrow squared plus plus, this is plus and not times, please. This is plus and not multiplication. Okay, so plus SC plus XC squared. Okay, then we are also told that the current is equals to what? It's equals to voltage all over Z all over the impedance. Okay, so if you know this, it means I will first of all find this impedance. Voltage is already given to you here. Okay, so to find this impedance, substitute these values that are given to you. So you have, which means you have square root of is 30 squared plus what? Plus 40 squared. Okay, so this will give you 900 plus 1600. Okay, so by the time you work all this out, you find out that your impedance is equals to 50 ohms. It's equals to 50 ohms. So if you substitute into this value, voltage is 200 volts, so you have 200 all over what? 50. So if you work this out, you are going to have that the current in the system is equals to 4 amp. Okay, so this is a jam question and you are not expected to waste too much time, but it has to do with your understanding of the question that is given to you. Is that clear? So if you understand the question, it will be easier for you to manipulate and then get your answers immediately. Alright, so I hope this is clear, and then we're moving forward again. Okay, so this is another circuit arrangement. This is another circuit arrangement, and this one has to be do with inductor and capacitor. So in an inductor-capacitor arrangement, which is AC series circuit arrangement, we have that the impedance is equal to square root is the square root of the sum or the difference of the squares of the inductive reactance and the capacitive reactance. So actually, by the time you have this equation, this is what you have, and then the peak current is equals to the voltage all over the impedance, just like we had before. Voltage all over the impedance, and then the overall voltage flowing through the system is equals to the square root of the difference of the squares or the voltage through the inductor and then the voltage through the capacitor. Okay, so and that gives us this. So these are basically the major equation. The important thing is for you to know how to apply these equations. Okay, that is what is more important, how to apply these equations. Okay, so we're going to solve problems so that you'll see how to apply the equation. All right. Okay, so this is a question that we need to solve. So that the frequency of an AC circuit, okay, so this is the AC circuit. So the frequency of an AC circuit below is 50 all over pi hertz. What is the reactance in this circuit? Okay, so if you look at this circuit, you are giving the inductance of this inductor and then the capacitance of this capacitor. Then this is the frequency, and then the voltage is not given to you, so you are asked to find the frequency of this particular circuit arrangement. All right, so before you can find the frequency, let us just bring out what is given to us. We are given the inductance of this circuit to be 0.9 hertz. You are giving the capacitance to be equals to 2 microfarad, and this is equals to 2 times 10 raised to power minus 6 coulomb or farad, as the case may be. Okay, the frequency is given to you to be equals to 500 over pi. Fine. Now you are asked to find the reactance of this particular circuit. The reactance of this circuit, which is the impedance, is equals to ZRC. Okay, ZL. This is ZL. This is ZR. This is Z. Let me write it proper label so that you will not get confused. Okay, this is ZLC, inductance and capacitance. Inductance and capacitor. So this is ZLC, and ZLC is equals to the difference of the square of the inductive reactance, and the capacitive, the square of the capacitive reactance. Alright, so which means that for us to solve this problem, we must find the inductive reactance and the capacitive reactance. We must look for those two. So, and that is exactly what we have to do first. Okay, so from this, inductive reactance equals to 2 pi FL. So substituting into this, you have 2 times pi times the frequency, which is 500 over pi, times L, which is 0.9 Henry. Okay, so you can multiply this, and then you have your XL to be equals to 900 ohm. This 900 ohm. Then XC, which is capacitive reactance, is equals to 1 all over 2 pi FC. Alright, so you substitute into this equation, you're going to have 1 all over 2 times pi times 500 all over pi times 2 times 10 raised to power minus 6. This pi will cancel out, and by the time you work all this out, you are going to have 500. We're going to have 500 ohm. So now you have gotten the capacitive reactance and the inductive reactance. Now you now substitute into this particular equation. So if you bring this out to this equation, you have square root of 900 square, square of 900 minus the square of 500 is a square root 810,000 minus 25000. Okay, so when you do that subtraction, you have 560,000, and then by the time you find the square root of this, you have 748. Okay, so please just press your calculator and then you have your values. Okay, so this is the reactance or the impedance of these circuits. I hope this is clear. Right, I hope this is clear, and then The important thing, as I said, is for you to understand the question and then know which of the equations to apply. All right. So I hope that is clear. So we'll move now to the other type of circuit arrangements. Okay, so this is the last type of circuit arrangement, and this circuit arrangement combines all the components of this that we have discussed before. So in this circuit arrangement, you have the resistor, the capacitor, and then the inductor. So this one is called resistor, inductor, capacitor series circuits. Okay, resistor, inductor, capacitor series circuit. So in this particular circuit arrangement, you have that the impedance is Z and is given as the square root of the resistance square plus. Okay, so if you remember this, you will find out that this is the impedance for an LC circuit, and this combines all the other ones together. Okay, so the peak current is equals to the voltage all over the impedance. That's what was mentioned before. Please don't forget this. Then the phase angle is equals to this, and then the total voltage that is flowing is equals to the square, or the square root of the square of the voltage in the resistor plus the difference of the square of the voltage of the inductor and the capacitor, and that is this. Okay, so as I've always said, the important thing is for you to know how to apply this equation. So let's solve a problem now. Fine. So this is a sample question, and the question says that an AC circuit of EMF 12 volts has a resistor of resistance 8 ohm connected in series to an inductor of inductive reactance 16 ohm and a capacitor of capacitive reactance 10 ohm. The current flow in the circuit is what? It's a jam question. So this question you are given the voltage to be equals to 12 volts. You are given resistance to be 8 ohm. So you are given XL to be equals to 16 ohm. You are given XC, which is capacitive reactance, to be equals to 10 ohms. Okay, so what you just need to do is you can either find the impedance or the impedance first, because current is given to you to be equals to voltage all over impedance, which is same thing as voltage all over square root R squared plus, this is in bracket, SL minus XC bracket squared. Okay, so yeah, voltage is already given to be 12. Resistance is given to be A squared plus XL 16 minus XC 10 bracket squared. So by the time you work this out, you are going to have 12 all over 64. There's still a square root here, please. 64 plus 16 minus 10 is 6. So you have 6 squared. Okay, so that is 12 all over square root 64 plus 6 squared is 36. So that will be 12 all over square root 100, which equals to 12 all over 10. So if you divide this, you have that the current flowing through the system is equals to 1.2 amp. 1.2 amp. Okay guys, so this is how to apply that equation to solve any problem that you might have. Alright, I hope this is clear. Please take your time to review the video again to get a better understanding and solve more problems. So this is your test your understanding page. Please, I want you to go through these questions and then try and solve them as much as you can. This one says that the resistance in a series RC circuit is 50 ohm. If the impedance of the circuit is 13 ohm, calculate the reactance of the capacitor. So you know that impedance is equals to the square root of the sum of the squares of the resistance and that of the capacity reactance. That's okay. So now they are saying that you calculate the capacity reactance. So from there you can solve this problem. I've already given you the hint on that. Then this one says that calculate the inductive reactance of the circuit below. Okay. So here you are looking for inductive reactance for that particular circuit as it is given to you. So in this circuit you have inductor and what? A resistor. Alright, so you should know inductive reactance. We just solve a problem there now, so you can solve for the inductive reactance. Already you have the inductance of the inductor there, so from there you can get your inductive reactance. Let's say if the current in this resistor is 0.5, don't forget that the same current that is flowing through the inductor. So the PD across resistor is the current times T. What inductive reactance? I think that should be easy for you to solve. Alright guys, so thank you so much for your time. It has been a little bit long in this class, but thanks, and I appreciate your time. Okay. So guys, before I leave, please subscribe to the channel if you are just joining us. Tell your friends. If you are an old subscriber, please tell your friends so that they can come and enjoy what you are enjoying. We appreciate you for coming back to our channel, and we continue to try our best to give you the best. Yes, and that is why you see that we take our time to bring out our lectures so that we'll make them to be as simple as possible for you, and then go straight to the points. We also try as much as possible to make sure that we explain our topics and to make them very simple for your better understanding. If you are a newbie to physics, at least if you follow our series right from the beginning, you become a better physics student. So thank you so much. If you have any problem, just reach us through the WhatsApp number that's showing on your screen, or you can put your problem or your questions on the comment section, right? So we appreciate you, and we hope to see you in our next video. I remain Otobo Michael, your online tutor. Thanks, and remain blessed. Enjoy your day. Thank you so much.